Can you see that, fellas?
Mm-hmm.
Yep.
Right. Okay, welcome chaps. How does the internet work? This little lecture is, there might be some technical points in there that people might find fault with. I don't care. I'm just going to teach you enough for you to understand a little bit more about what's going on and give you a bigger picture. And it could be that you already know some of this stuff, in which case feel free to contribute. So do any of you have any idea how the internet works? And no is a perfectly good answer, as ever.
Not particularly.
I've heard a couple things before in my own learning, but not that I can remember clearly.
Okay. So let's have a look at your local network at home. So we're going to start off by learning about how network traffic gets routed at a very high level, and then we're gonna just progress through kind of what happens with the internet, and then ultimately how does that relate to what you've already been doing. All right. So you can see on the picture there, you've got your laptop and your phone, and certainly in my house, I've got a router which has got a Wi-Fi signal and an Ethernet plug-in, right? So I can plug network cables in. And I've also got a modem. Now they both came from BT. It used to be that the modem and the router were all one piece of kit with BT, but now for whatever reason, there's two pieces, right? And I've also got a Freeview box, and the Freeview box is actually connected with a wire because it wants to pull off television signals. A nice expression, and there's a lot of data there, right? You don't want to be shipping buckets and buckets of data over Wi-Fi when your Freeview box is right next door. Plug the cable in, it's going to be quicker. Okay. And the modem then connects to my ISP, which in my case is BT. All right. But how do packets of information get passed between the machines? How do they know where to go? So my machine has got one of these internet protocol addresses, okay, an IP address, 192.168.0.1. That's what my laptop currently has. My telephone has got another one. It's .2. Freeview box, .3. I mean, this might not be accurate, right? They might be slightly different. But the idea is that each of these devices has got one of these, effectively, what's that, 12-digit address. There's 3, there's another 3, and there's another 3. I could put 00 and 001, but people don't do that by convention, okay? So there's a 12-digit number, I guess like a phone number, which says, this is my address on the network. And the modem has got quite a different address. I mean, most of it's similar, but it's sitting here at the top end of the range. So these numbers range from 0 to 255, I believe. Okay, so each one of these sections could range from 0 to 255. I wish I had my notes, bear with me. Okay, let me just take a step back here. Right, so I'm going to read these notes out in case you can't see them. So this local network exists between your devices and the internet service provider. Okay, all of this is the local network, and the router takes care of directing traffic from here over to the ISP, or from my device to the router and back to my other device. Or if I want to watch the Freeview box on my camera, that might be on my camera, on my telephone, that might be possible. And of course, the router then passes out your signal out to the internet if you need to get things from the internet, right? At the moment, you're probably not doing much with your computer and your telephone. You're not connecting those very often, almost never, I would think. I don't do it. Okay. So all of these devices have got an IP address and that allows the network router, okay, that's why it's called a router, it's deciding where your traffic goes. And the way it decides that is it says, so let's say my device wants to go to the BBC, it finds out where the BBC is, and it passes the information from here to the router, to the modem, to the internet service provider, and the get signal goes off to the BBC website, says, hey, give me some information, and then it all goes routing its way back. And it does that by using a series of these addresses, okay? That's just how it works. So let's try and resume this here. Oh, look at this. Oh, presenter view. Cool. Ah, that's no good. Okay. So the modem or the router, look at that. Jesus. Go away. Takes care of creating the home network. Okay. And by that, I mean it allocates an IP address to each of these things. So when you turn on these things and they connect to the router, there'll be a few seconds while it says authenticating, and if you're very quick with your eyeballs, you'll see it will be getting an IP address, okay, so that the router can then find it. And this whole router modem thing is sometimes called a gateway, okay, so the gateway to the internet or the outside network. And you can see this for yourself in Windows. If you go to the search bar down here and type CMD to get the command prompt, and actually, Alex and Mike, I'd like you to do this. Fraser, I don't know how this works on a Mac, so I'm not even going to attempt it.
I've got the I've got a shortcut to the command.
Okay, cool. And in Windows, then once you've got the command prompt open, type ipconfig/all.
Mm.
And if you just briefly head back to my screen here, you can see that I'm looking at my wireless LAN adapter, okay, which is my Wi-Fi chip in this laptop. And my Internet Protocol version 4 address is actually 192.168.1.213. Okay, so I got the number wrong on my slide, but that doesn't matter. You get the point. It has an address. Can you boys tell me what your addresses are?
No.
Okay.
Oh, I mean, sorry, Alex.
Yeah, yeah. Mine is 192.168.1.151.
Okay. And what about your default gateway?
192.168.1.1.
Okay, so what that's saying is the first thing on your network is the gateway itself.
Mm-hmm.
Okay, and I've got this thing here, DHCP server. I was too lazy to look up what that means, but I think it is the I think it's the IP address allocation system. And as I said, the thing that doles out the IP addresses is my gateway, i.e. the modem and the router. So if I want to get out to the outside world, my network traffic goes through number 254. And if I want to get a new IP address, connect a new telephone to my home network, it will also go to 254 to get its IP address. And there's this other one down here, DNS servers. Can you see that?
Yep.
And what's your DNS server?
It's the same as the default gateway.
Okay. And we'll find out what DNS means in a second. All right, so that's a way for you to see your IP address, okay? The physical address of your machine. And we don't really need to understand it too much, but it's just a bit of starting background. So what did I say? I said the modem and the router creates your home network, and you can see that on my screen here outlined in gray. It's my home network. And all these network addresses, these IP addresses, they're all very similar. Look, 192.168.0.3, 0.1, 0.2. And you'll find that all of yours are as well. And this is because it's the home network and it's actually hidden from everyone else's network. So this is why all four of us have an IP address, which is something like 192.168.something. This convention here, 192.168, that by convention is your home network. Now, your home network and my home network are different, right? I can't see your machine. And that's because this home network is shielded by the modem. Everything to the left of the modem is on my home network, which by convention starts 192.168, same as you guys. But there's a bigger network outside, which I get to by going through my modem, and my modem's also on that network. Okay, so my device and my Freeview box and my telephone, they aren't on the external network, but this modem works as a bridge between my network and the outside world.
Mm-hmm.
So stuff that's out on the internet comes into the modem and then gets translated from this address to, haha, we'll go on to the other network now. And this is why you'll see often in a modem, if you've ever had troubles, you'll often see firewalls built into them, which says, hey, when people are trying to hack my home network, don't let them do it. That's what a firewall's job is, to stop undesirable traffic coming in. Okay. And you can see that although I've used letters, I've really used letters to demonstrate that they're different values to this by convention internal network. So how does it work with the local network to the internet? Okay. So we've already discussed this gray box is the local network. The green box is the outside world, and my modem is in both. So when I want to get some information, I put in the IP address of the thing that I want, say the BBC web server, and off it goes to the web server, and the web server's job is to provide routing to other machines on the big wide world, and to websites and to files. So you've probably heard of a file server, which is a server out in the internet that gives you files, as opposed to a web server which gives you web pages. But I bet none of you have ever typed in the BBC's IP address, right? 172.025.13.6.
No.
Right. I wouldn't try that. I've just made that number up. I have no idea what the BBC's IP address is. But you can see why we have names for web servers.
Mm-hmm.
Because remembering IP addresses is horrible, right? No one wants to remember those strings of numbers. So when I'm going to the bbc.co.uk, in what way is that a series of numbers? Well, let's just quickly go over a few terms here, right? URL is a uniform resource locator, and a URI is a uniform resource indicator. You don't need to understand what those things mean, but basically, and there is a subtle difference between them, but to all intents and purposes, it means a web address. So if you hear me say URI or URL, I pretty much mean this phrase here, this whole chunk. Do any of you know what HTTPS stands for?
I know it means it's safe and secure, but I don't know what it stands for.
Okay. Other chaps?
No, again, I've come across it, but I couldn't tell you.
Look at that, Hypertext Transfer Protocol, and the S is secure. So this is a funny word, protocol, and in networking, what it means is the shape of the signals that are being sent. You know, like polite society protocol in martial arts is you walk in somewhere and you bow, and you go to the master and you bow to them, and then you shake their hands. And in when you meet people and you're not in the martial arts world, you go and say hello, how are you, and you shake your hands. And that's a protocol, right? That's the agreed way of treating each other. And what HTTPS is, whatever this crazy word, hypertext transfer, it's just a way of saying, I'm going to push some numbers and letters from my IP address to your IP address, from the BBC's IP address to your IP address. using a protocol called hypertext transfer. Right, one second. Hang on, because I'm being tapped here. So yeah, HTTPS, hypertext transfer protocol. It's an agreed system of pushing characters over the network, and the S just means instead of it being plain text that's pushed over the network, it's encrypted and is therefore secure. So people can't just read it and go, hey, look, Alex is downloading more lesbian porn. They can't see that because it's been, man, I wish I hadn't said that on this recording. Apologies, Alex. The secure bit means it's encrypted, so people can't read that text over the internet. BBC, this is the domain name. Okay.
Guys,
You might be
can
tempted to
you
think
share
that this
again?
is all the domain name. And the domain name basically means, well, the BBC's domain, as you can imagine, domain means their stuff.
Jace,
Yeah,
You're sharing your screen.
screen share, please.
I'm not sharing my screen.
No, not currently.
Excellent. That's good. Okay, let's go back. That's working now, right? No, share that. There we go. Share Chimpy.
Cheers.
Okay, so BBC is the domain name. And actually, you probably technically say .co.bbc.co.uk is the full domain name. And the .co.uk is called the top level domain, or the TLD. Now you're all familiar with .com, .co.uk, .nz for New Zealand, all of that sort of stuff. There are new top level domain names like .ninja, which is cool, and I've got one called .menu for my local menu website. So you can buy these top level domains. They're kind of a business asset. So earlier we looked at the word DNS, and we're talking now about why is it you don't need to put the BBC's IP address into your browser? How come you can type bbc.co.uk and it magically works out the internet address, the IP address, the internet protocol address? Okay, so DNS stands for Domain Name Server. And this is what it does. You type in BBC and the domain name server is a list. When your network traffic goes to figure out where to go, it must first, when you've typed in a domain name, it first goes to the list, it goes down the list, it finds BBC, and it looks for the IP address. And then it uses that IP address to route your request to the BBC, and the BBC to then give you a response, and it gets routed back to your IP address. Okay? And the BBC website, being a machine, doesn't need to know mikekavanagh.com is actually 192.168.0.1. It just uses the number, right? Domain names are easier to remember. Well, that's the reason we've got them. And there are multiple domain name servers all around the world. So when you go and buy yourself FraserSalisbury.rocks, okay, there's a top level domain called .rocks. So you go buy FraserSalisbury.rocks, you own that now, but it will take a while for the domain name servers to be updated with whatever your web server is. So say you wanted to make your own website, Fraser, and host it on the internet, you buy yourself a domain name, you know what your IP address is because you know where your web server is, because otherwise you've no business really trying to set up a website on it, because you need a thing to put a thing on a thing. And that will then circulate around the planet, and eventually all of the domain name servers will have an entry for FraserSalisbury.rocks with the IP address of his website. And that can happen really quickly, but normally you'll see a little message saying, oh, it'll take up to 24 hours to update. Okay, so here we are. We're on my computer here. I type in bbc.co.uk. My local network traffic gets routed to the modem. The modem then goes from my 192 network to the internet service provider's network. It doesn't know what bbc.co.uk actually means, so it goes off to a domain name server and gets the IP address. And then once it's got the IP address, it's able to route your traffic to the BBC's web server, which we call bbc.co.uk, but the internet calls whatever that figure is. And the web server's job then is to say, hey, Jace wants some web pages. So it finds the pages that I want and sends them back. Simples. Conceptually, it's simple. Does that all make sense?
Mm-hmm.
Yeah.
Mm-hmm.
Yeah.
Cool. Do you think you know a bit more now than you did?
Yeah, definitely.
Cool. Okay, that's good. There could be chaos if a terrorist, I say chaos, actually it probably would be reasonably chaotic if someone blew up all the domain name servers. That would have quite an impact on the internet.
How many are there?
I don't know. But of course, what can happen is people's machines will cache domain lookups. So if you go to the BBC, 20 times a day, and your internet service provider, your network routing keeps going to DNS to get the IP address, right? Chances are the BBC's web address, IP address, doesn't change that often.
So
Kind of
just
by definition, you don't want it being fluid. So it's quite possible that your machine has got its own local cache of the common things that you go to. So there'll be a name and an IP address, and you look it up locally, which is much quicker. I say the system will look it up locally, which is much quicker than doing this whole round trip just to get the address. Right. So how does that have any relevance at all to us? So let's have a look at our development environment. Here's a cut down picture of the real world. Right, I've put the router and modem together. And you're now familiar with this diagram. But when we're doing our development with Visual Studio, we don't have all of this shizzle. All of this technique here is compressed and running on your machine. And if you were to disconnect from any part of your network or turn your router off, right, so long as your Mac's still on or your PC's still on, you can do all of your programming. And it's because your computer is actually, Visual Studio is emulating all of this for you. So never once have we had to go and push your software out to the internet for you to test it and get it working. It's all running on your box, which is really cool, which is much cheaper, obviously, and much less grief than trying to find a web server on the internet and hosting your stuff on it. But here's an interesting question. Could you host a website here on your computer and have someone else on the other side of the world look at it? Well, the answer is kind of no, I think. Maybe it's yes, but probably no. Because your device here is on your private network. The only thing the rest of the world can see is your internet service provider's, well, maybe at best, your modem. So if someone says, go to 192.168.0.jace, well, that isn't on the public network. By definition, the 192.168 addresses are all internal here in my house. So if someone wanted to get to my machine, they'd need to know the router's address and have some way then of the router going, oh, you've come to me and now you want to go to something on the 192 address range. Okay, and this is why people like us don't host something on our own machine for public consumption, because it's not designed for that. And also, of course, you turn off your machine. And also, of course, when you join your network, you might get a different IP address. So it's no good for other people because your IP address is always changing and is always hidden behind your firewall and your router. So that's why you can't just host frasersalisbury.rocks on your Mac, Fraser, and hope that Matty can see it, because it isn't on the internet, it's on your private network. BBC web server's on the internet, but your personal machine isn't. Okay. So we've had a look at how this big picture works, and we are saying that it's all squashed onto your machine for your development. So let's have a zoom in on that. We've got Chrome, which is our web browser, and in Fraser's case, probably Safari. And in fact, any web browser, I've just picked Chrome because that's what I use. And when we're doing our development, Visual Studio is where we're writing our code. And when we push the run button, it does a number of things. First of all, it creates and sets up a web server. And you'll notice when you hit your play button, it says IIS Express. That is the name of the web server. Okay, it's like a brand name. There are other web servers. I know, Mike, you've been working with Node.js web servers. And that is similarly, it's a web server that you can run on your machine. And we'll talk about web servers in a second. So Visual Studio is creating a web server so that Chrome can talk to it. Okay. Using the network system. So your machine is 192.168.0. something. Your web server is on the same network. So the router is able to, or the network card in your machine is able to go from here to here without going out to the internet. Okay, because you're all on the same IP address. So you're already in the same sort of area. So Visual Studio starts a web server, and it takes the code that you've written and it compiles it into what are called DLLs, right? Dynamic link libraries. Go figure, doesn't matter what they're called, but the code that you've written gets compiled into files, dumped in a special place in the file system that the web server has access to. So when you say in here, roll 1, your browser actually navigates to the web server. And then the web server says, oh, you want dice/roll1. And it maps that request, dice/roll1, to one of these DLLs. Okay, and the DLL is just your source code that's been compiled and can run in the .NET runtime environment. So let's talk about web servers. So the purpose of a web server is to handle an incoming request from a browser and serve up a response to it. So our domain name is localhost. All right, when you run IIS, your domain name, you could type in 192.168.0.1/dice/roll1. But it's much easier to just call it localhost. And this is a convention again. The web server knows, well, the network card knows that if you're going to localhost, it's an internal thing to your machine, right? So our domain name is localhost rather than bbc.co.uk. But it's still, there's a little DNS block somewhere in your machine which is going, localhost is this machine, 192.168, blah, blah, blah. Okay, so we're saying I want to get a web page called dice/roll1. So that's our get request. It hits the web server, which is called localhost, and it has an IP address. And the web server is being run by a system called IIS Express, or that is the web server. And the web server says, okay, you want dice/roll1, so it finds the dice/roll1 code, runs it, captures the response from it, and then funnels the response back to your browser. And you could move this, you could leave this on your machine, move this out to Azure Cloud or Amazon Cloud or some other cloud system. And you could have this on yet another system, and the web server will do all that routing and figuring out where to go. all right? But it's all compressed down. So this is what happens when you go to the BBC, but it does it across the internet instead of a single machine. So let's have another bit of a dive here. We know that when a request comes in, the server handles it, figures out what to do, and sends a response back. So how does this work with our, I'll tell you what, let's take a step back. Does that all make sense to you fellas?
Mm-hmm.
Cool. Is it giving you a bit more insight as to what's going on?
Yeah.
Yeah.
Okay. So I know we haven't done any of that. All we've done is fire up Visual Studio and make a website, and it's all magically worked. But hopefully now you've got a slightly better understanding of how that works, and how in fact we could start, if we want, we could go and put our code out on the internet and have that working. And our browser would still be on our machine. The web server, we'd need to either know the IP address for it, or we'd need to buy a domain name and put an entry in the DNS to say Jace's sample code is at some IP address. And then we'd need to deploy our website somewhere where the web server can get to the code. Now, we normally deploy our code actually onto a web server, right? Because it's quicker. It's quicker for a web server to say, "Oh, this code is running locally. I'll spit out my response." Okay, it's possible for us to separate out web server and the actual machine that has the code on it, but then often one machine. So we could do that. We could publish all our thing, and you could show it to all your family. Go, hey, look at my Monopoly game. And that is ultimately what we'll do when we finish this project. Is we'll learn how to ship all this onto the Azure platform, because that's what companies are doing these days. They're hosting their software in the cloud. So you need that skill, and you need to understand the difference between it running on your machine and it running on the cloud. Okay, so we're using this system called .NET Core in specifically, and we're using a web pattern called MVC, Model View Controller. We already know about our first model is the D6, and you guys have already been creating views, and you've been adding controllers, the dice controller, and you've been adding methods to, or actions to the controller, roll 1, roll 2, whatever. So how does this work? Right, you'll remember I said the signal comes into the web server decides what to do with it, and then goes to the right part of your code on the file system and runs the code and feeds the response back. And the way the web server does this, and this is our web server, right? It's not Node, it's not Tomcat, it's not any of the other web servers that are out there. This is a .NET server, .NET web server. And what it does is it looks for this first part here and says, well, by convention, that first part of the URL is the controller. So we go to our dice controller. And the thing we want to do is call the roll 1 action. And the controller's job here is to glue together the model and the appropriate view. So we know that roll 1 has got a roll 1 view, and we know that the model it uses is D6. And the controller's part in this design pattern is to take the incoming signal, right, from the web server, take the incoming signal and route it to the correct controller, dice controller, and to the specific action on that controller, roll 1, roll 2, get a list, whatever. And the controller's job is to get the correct model, get the correct view, glue them together, and spit out the results back to the browser. So we know we've got a dice controller, we've got an action, we've got the model, we've got the view. And if you look at your source code, it will be in a folder called views, dice, and it'll be roll 1 CSHTML. And hopefully you're all familiar with that now. You go back. Okay, any questions?
No, not so far.
Okay.
No?
Nope.
So it's important to understand that the web server here is operating against this controller view model sort of idea. So you've all seen URLs like this. Maybe it's role1.index or role1.html or role1.php, whatever. It's the web server's job to interpret what the user types in here. And in our .NET world, this is the convention we use currently, controller. It's called MVC, Model View Controller, but actually it should probably be called controller with a view and a model, right? So let's have a look here. This animation doesn't look good. Oh no, it's okay. So that view that we spit out, okay, when the controller's decided that you want the role1 view, it goes and looks for it. And that view is comprised of Razor code, which is a .NET kind of code, okay? Razor runs in the .NET platform. It's got some bog standard HTML in our view. So if you go and look at your role1, you'll see some H1 tags for heading 1, and you'll see some paragraph tags and other bits of HTML, but you'll also see this Razor. And it might also use a partial view. And we'll learn about partial views when Mike's done his work, right? Because Mike's already using partial views, which is cool. And what the controller's doing here is gets the view, gets our model, and all of this view here, comprising of all these different things, gets munged into the response signal, and the response signal goes back to the browser. And what the browser does is it takes, so let me take a step back. So this Razor code is C#-like code, HTML is HTML. And when this thing is constructed and squirted out, the Razor code is converted into HTML code. So what you get at the end here is a nice HTML web page which your browser can draw. Okay, and the HTML will have links to your style sheet, so we know we're using Bootstrap. We've also got our own specific CSS style sheet, and any others that we might want to use. And you'll also see in there some jQuery, links to jQuery, which is a JavaScript library, any of our own JavaScript that we want, and any other assets like pictures of dice. Okay. So Alex, I think that's it. Alex, could you share your screen for a minute, please?
Sure. 1 second. Okay.
And if you could just run your software there. You're good. You clicked on IIS Express, and now you know that it's firing up a web server. And it's also, because it knows you want to use the web server, it's firing up your default browser for you. And there's our website. Now, if you right click, actually go and hit rolled. Okay, and right click and choose view source. That's it. So this is the HTML that's been squirted out. And we can see at the top, we've got standard HTML opening tags there. HTML language equals English. We've got the header section, and we've got a link to the Bootstrap style sheet and another link to the site CSS, which is your own CSS file, which Visual Studio's put in there for you by default, okay, in your project. Unless you added it, I forget. And at the bottom, you'll probably see some included JavaScript. Yeah, so that's pulling in some JavaScript files and elsewhere. Okay, we don't have any pictures in here, so we haven't quite got the assets part of my slide. But it's important to understand that what's happened is the .NET MVC website that we're using has taken your code and squirted out what looks like perfectly good HTML for the browser to understand. So it's good to know that the languages that you're learning and writing ultimately produce this, and this is what's shown to the user. Okay. So if you could just keep that running, but swap back to Visual Studio. Cheerio, lovey, and let's have a look. Right, okay, and let's have a look at role 2 CSHTML. Okay, now you're wondering, how on earth did this tiny amount of code become all that HTML in the web page? Because there's much more, isn't there?
Mm-hmm.
Okay, so let's have a quick recap. So at the top there, where you've got at model and any of these ats that are in yellow, that is Razor code. Okay, and anything without the at is normal HTML. So this is what I was saying in my presentation there. On your web server side, you've got a Razor, chunk of Razor, a chunk of HTML, and they're being munged together. When your request comes in to get your page, the web server looks to the DLLs that you've created by pushing the play button, and it runs them. And in running them, they convert themselves from this lovely code that you can understand and read into HTML code, which is less elegant, perhaps, arguably. And why is there more? Well, you'll remember that our views also have that shared view. And that shared view had the header section with the menus, and it had the bit at the bottom with the script. So you could go and hunt through Visual Studio now and find, you see at the bottom there, the footer class.
Yep.
That's been added into your view by Visual Studio. So let's just go have a look at the footer class again in Visual Studio and go into shared layout CSHTML. Okay, so there's our menu at the top section. On navigating, right? There's all our links. And then right in the middle section there, line 41, there's a little area there which says render body. And what that means, that's some Razor code which is saying, hey, go and take the main bit of view that we care about, which is role 2, and glue it in here. And then at the bottom, you can see the footer code. So even though when we look at role 2, we've only got a little bit of code, it's being composited into a bigger thing, which includes this code, all right? And then the Razor's being interpreted and being squirted out as HTML. So ultimately what you get coming down the wire is perfectly good HTML that is running in the browser. Okay, let's hit the stop button. And I'm going to pause the recording. Actually, I'm not. So has that helped clear up a sort of a larger overview of what we've been doing?
Mm-hmm.
Yeah.
Yeah.
So when you type that URL into the browser, it goes and looks for the right bit of code, munges it all together and squirts it back out. And that's basically what we're doing for most of our website. Cool. And we'll come back to that diagram and layer on more software architecture. So one of the next things we're going to do is learn how to save some information from a web page to your disk. So when you come back, it's there again. Okay. Right. Let's just pause this. Why don't you fellas now get yourselves 6 dice image, one for each side of the dice. Just quickly have a look on the internet. And actually, I'll tell you what, let me give you some instruction. Stop your web servers. So if your website's running, stop it.
Mm-hmm.
Then go up to the Solution Explorer to www root and click on that. And then you should see, Alex, could you share your screen, please?
Yep.
Root. Oh yeah, I got it.
Yeah.
Yep.
So if you open up that magic folder, you've got CSS, JavaScript, and lib. And if you just quickly have a quick look in each of those, you've got your site CSS, your site JavaScript, and a whole load of other scripts there. Okay. So what I want you to do now is click back on root and add a folder called assets or images or whatever you like. And you'll remember we did something like this in our very first web server example. And what I want you to do is, okay, thanks. What you're going to do now, you can stop sharing, Alex, is you're each going to go and find some dice images that you're happy with. And in fact, just find one dice image for now, because you can use the same one and you can update it at leisure, all right? So find yourself some dice images with the values that you want and put them in that folder. Actually, you might as well get 6 images. Mike, did you find yours were easy to find?
No, I had to get a block of 6 and then print screen it and then cut out them individually.
Did you?
Yeah, so I couldn't find. So if Fraser and Alex, if you find just like, I'm just saying, if you can just find one that's just got like 1 dot and another with 6, that would probably exemplify it, wouldn't it, Jace?
Yeah. We don't.
Yeah.
I mean, ideally, you'll get all 6, but once you've got 2 of them, that's enough for our exercise.
Yeah, just try and find 2.
Yeah.
What is it? Any specifically 1 and 6, or just any random?
Any of the numbers.
If you do a PNG, will
That'll be okay.
yeah, okay.
Yeah, they should all be fine. I think mine would. No, mine were probably PNGs actually.
I hear today, fellas, that you boys are going to have to be swabbed before you're allowed home for Christmas.
Yeah.
Oh wait, I didn't realise that.
Yeah, it was on the news today. The government is somehow trying to allocate you all appropriate times for when you're allowed to come home for Christmas, and you've got to travel on that specific day if you're going by train. But how on earth that's going to be enforced is beyond me. And there is talk about them forcing you to have a test first, 24 hours beforehand. And there's only any point doing that if they're actually going to stop you after they've tested you.
The logistics of that must be huge.
Yeah, I think it's the old, let's hope everyone follows the rules kind of approach, because you can't enforce that, right?
No, not at all. That is huge. I know my uncle was involved in track and trace currently, and he just says that it's unbelievable the amount of work that's going on behind the scenes.
Right.
Just like they're getting terabytes and terabytes and terabytes of data every day that they're sifting through and trying to deal with and
Blimey.
set up the infrastructure, and it's ridiculous.
Yeah.
So like trying to organise that and book everyone in for tests and assign the test to the right person and get it all sent back to the right phone number, all within 24 hours.
Yeah, it's pretty hardcore.
Yeah. So I was thinking that you know how they had the problem with the pubs in London, that just everyone left the pubs at 10 o'clock. They didn't, and everyone got onto the tube at the same time. I thought that would just be the same problem with all the students. Everyone's going to try and get back at exactly the same point.
Yeah, well, I think they're allocating like a day or something for everyone.
Yeah, I think each uni has a different day or set of dates they do it.
Oh, right.
I don't think, because originally I thought it'd be pretty stupid if every single university went back on the same day.
Yeah, but they're going to try and stagger them.
Yeah.
Yeah, okay, so so it would be one day they'd do Sheffield and one day they'd do Sheffield Hallam sort of thing.
Mm-hmm.
Yeah.
Okay, Mike, because you've done this work, I'd quite like you to do it without the shared view to start with.
Yeah.
So what we're doing there is introducing the problem, and then we'll introduce the solution. But if you could teach these boys what you did, just by them doing a screen share and you talking them through, if that's all right.
Yeah, so not with partial views, just the
Not with
original.
partial views to start with, just the
original.
yeah.
Yeah, absolutely.
Thanks.
Well, I can do my best, like without having my laptop here.
Yeah, no, and that's fine.
A week ago now, I can't really remember fully, but yeah, I'll give it a go.
We'll figure it out between us.
Yeah, I'm sure. Right, you two ready?
Yeah, I'm ready. Got two faces.
Cool.
Me
I don't
too.
know which one of you wants to.
I'll screen share a few.
Yeah, go for it.
Alex.
Okay, so the purpose of this bit of exercise is we're going to display the matching dice value for the value that you've rolled, right?
Mm-hmm.
Cool.
Yeah, I'm just looking because I just did it on my own. So when we were, in the sprints, there was roll 2 dice. One of the optional bits was displaying the current value so that it renders out. So when you roll it, it will come out and say whatever. So what am I looking at?
So this is the view for the roll 2.
Yeah, I'm just trying to remember how it comes out. So that comes out currently, doesn't it? Just saying you rolled.
Yeah.
It just says a 3, a 2, or whatever.
So, yeah, it says 1, 2, and then if it's a double, it says you rolled a double. But that's it. Just the number.
Yeah. Okay. Oh, this is awkward to try and remember now.
Well, that's okay. Don't worry about the layout, Mike.
Yeah, no, I'm just trying to remember how I. So what we want to do is write a bit of code that will say, if a 1 is rolled, display image 1. If 2 is rolled, display image 2. So the way I did it, it was pretty simple code. Alex, are you familiar with if statements?
Yeah.
Yes, you are sort of, or I don't know what you've done with Python.
Yeah.
But Fraser, are you familiar with if statements?
Kind of, yeah.
Yeah, so you want to, so your first line needs to be an if statement saying that if the model.firstDice.current value is equal to 1, so the notation, you'd need the brackets around the model.
There's a nice example on line 13.
Yeah, they go on line 13 like that.
Oh, okay.
So, so as it's in Razor, you need the at first.
Yep. So if model is,
and then say first dice. Oh no, sorry. Remove that all the way down to the dot.
Right down to.
Yeah, remove is. Well, you've got that right there. Yeah, dot first dice and the parentheses at the ends there. Oh no, sorry. The earrings. Remove the inner earrings there because first dice isn't a function.
Yeah.
Models at first dice dot current value. So we're trying to nail in on saying if the roll is, then we do 2 equals.
What inside the
yeah, inside, because this is the conditional statement.
Yeah.
It's equal to 1.
To 1.
What number do you have? For,
so I just got 3.
You've got 3, yeah. So if it's equal to 3, and then at the end do the curly brackets.
Well, it's similar to that, but it would just
yeah, like that.
Let's call that a code block.
Yeah.
If we say code block, then we want the curly brackets.
Yeah. Okay. So
do I just drag the image there?
Yeah, perfect. And then you just drag that into there. Or do it for 6, because 6.
Yeah. I tell you what, drag it outside of the code block for a moment. See if that works. Oh, okay, that's a shame. It works in our systems.
Can you?
Yeah, so when I tried doing it with actually the first website, I could. That's why I ended up doing a GIF, because it wouldn't work for a picture for some reason.
Okay.
Can you right click and copy it, or?
It wasn't as simple. Yeah.
What we want is, sorry, I'm just getting up. If you do the angled like arrow brackets,
What? Those ones?
yeah, but open it. So if that's a closing one,
Yeah.
do the opposite, and then you put IMG space,
Oh, and then it's named Dice Face.
then SRC, so the source of it, and then equals, and then you want to do like a squiggle that's normally above the hashtag.
Tilde, I think.
Yeah, tilde.
Yeah.
Yeah, and then you do a /, and then dice. I don't know how you
I
would
think
do
it's
it.
assets. I've got it up here. I might.
Yeah, well,
I've just copied
yeah.
it.
What have you got?
It'd be assets / and then the name of your file.
Do I just do the spaces as?
I'd probably put a hyphen in there.
It did a space on mine, so I
Did it? Okay, cool.
I think it might work. .png as well, and then afterwards space / and then
Like
yeah,
that.
there.
Okay.
Yeah, perfect.
Try running that.
Yeah, so
Can
hopefully.
you see a bug in that? It's not really a syntactic bug.
I was in this bit here.
Well, no, you're saying if it's number 3, put the image for number 6.
Oh yeah.
yeah,
that was
yeah. Okay, well.
Just
Yeah, if you just change the value to 6 there, Fraser. And then make sure it's saved, or I always save it before I run it.
Oh, for what it's worth, when you hit the run button, it will generally save all open files for you.
All right, okay.
Okay.
So all that shit that's going on in the screen there, that's Visual Studio compiling it to those DLLs and writing them to the file system.
So now, so Fraser, if you go back to it, if you hit refresh a couple times, just on the roll 2.
Just till I get a. Oof.
Oh, you got one.
So you banged a 6, and there you go.
Check it out.
Looks pretty horrible, but I guess.
Yeah, yeah, it's not pretty, but formatting it
Yeah.
isn't too bad. So what we would do if we go back to the code, what I did was I started with equals to 1.
Yeah.
Because I had the images for 6, and then at the end of the code block,
Yeah.
just on like outside of the code block. If you, or no, sorry, still on line 23, just outside of the code block.
Yeah.
If you type else if, else, I don't know, is it a space in between with
It is,
C#?
Yeah.
Yeah.
Mhm.
And then you would open another code block. Yeah, and then just hit enter in the middle. And then you would repeat, and then else if, and then you would have models first dot, and then the next image. And then every time you would,
Okay.
so when it hits 1, you'd get 1, and when you get 2, it'd come up with 2.
What's the benefit of doing that instead of just copying? Say I just copied and pasted this.
Yeah, you would copy that, but the else if, it, from my understanding of it, is, I don't know, Jason, would it work if you just had several if statements?
It would do. The benefit of using else is it will probably need to do less work, but I wouldn't worry about it doing less work. I would just copy exactly what you've got and change the number. I don't think we need to worry about the else.
Yeah, I'll bounce to Jason on that. But yeah, you would just, I just did it with else if statements, and then you just copy and paste it for each of them.
Mm-hmm.
And then every time you would roll it. But then I did it. Oh God, this is weird trying to remember what I wrote. Because you need to get 2 dice on there.
Yeah.
So I can't remember. Did I have? Yeah. So I'm trying to think of how to explain it, because I had I did the formatting for it at the same time. So I had 2 different Jace, you know what I'm trying to say, don't you?
Yeah.
I had the grid layout going. So
Okay.
while I was writing them, so I wrote the 2 containers or whatever. There we go. What's gone wrong with that one?
Just a problem with the picture. I probably just downloaded a dodgy one, I reckon.
Oh, right, that's a 3. Yeah.
Oh, it's a JPEG, not a PNG.
Yeah, that's
Okay.
probably.
Oh, okay.
Okay, so let's worry about layout later.
Yeah, I'm just struggling to trying to figure out how to explain it because I laid it out and then wrote the code into the layout. So
Right.
I'm trying to go backwards through it from memory without doing it myself. So I'm getting a bit lost in my brain.
That's all right. So let me take over for a sec. Nice job. How about doing the same thing now for the second dice? How do you get images for the second dice?
Well,
Oops, sorry.
no, you go for it,
You
Alex.
do the same, but instead of doing first dice in the if statement, you do second dice.
Yeah. Simples.
Mm-hmm.
So copy and paste those, my friend. Alex, have you now got 6 dice images?
I've just got one.
Okay.
If I've got a 2D one like Fraser's got, and you can just, I guess, edit it in Paint or whatever. Might be easy enough.
Yeah, well, I did, Alex. As I said, I just found a website where it had a block of 6 and then just screenshot them across.
Yeah.
Or I think I found like a random dice roller on the internet and just hit refresh until I had each like
Oh,
6
nice.
of them and just screenshotted them one at a time.
Cool.
It was a bit long to do, but.
How do I get that?
Boy, you got a 3. Now we need a 3 and a 6, don't we?
Oh, yeah. No.
Oh, you got a double. Check it
Oh.
out.
No, 6 and a 3.
Oh,
Nice.
that isn't. Hey, how? Ah, okay. Why did it say you've got a double?
I just refreshed it really quickly, so that was why.
Cool.
That was a previous one. It worked.
It works, yeah. I mean, it doesn't look nice, but that's fine. So the technology's there now. You could have nicer images and you could have all 6 values, right?
Mm-hmm.
So that's good. Oh, hang on a sec. Come here, little boy. I think that's the dog wanting his dinner.
Moss?
It is Mossy, yeah. Actually, let's ignore him. Okay, so that's good. Alex, can we see yours? Is it similar?
Yeah, it's very similar. I'm in the middle of making the dice right now, but
Okay. Don't worry then.
Okay.
Okay.
Yes, because I need to bounce now. I've got to get back into Burgess Hill, back to the unit to pick up my brother who's working at the store.
Okay.
Mm-hmm.
So, fellas, is it home time?
Yeah, for me it is.
Okay.
I mean, I can give you boys another half an hour if you want to carry on with this. It'll only be doing stuff that Mike's done, so you won't be missing anything.
Okay. I would like to know about the ELSIF statement, just so I can squish it down a bit rather than having 12.
It doesn't. Well,
Does it make
we'll
it any
get
smaller?
into the. I guess we'd get into that a bit more of the partial views next time. But
Okay.
the first time I did it, it was just 12 statements. Like
Right.
Yeah.
2 blocks
Actually,
of 6.
I'd like to get to that point today with these boys. So if you fellas can even if you use the same images, actually, do you know what? Spend 5 minutes finding some more images. All right, and we'll pick up again in a second.
Okay.
So I'm going to go down and give the doggy some food. I'm going to say goodbye to Louise. Bye, Louise.
Bye. Yeah, I was going to say bye, Louise, then for a second. Yeah, sure, that's me. What I was just going to say, while we're all here, when were we next going to meet? Because I think
nearly Shakespearean. When shall we four meet again? Friday?
I think we had Wednesday. We had tomorrow and Saturday free.
Okay. I'm working tomorrow, so I can't.
Saturday works well for me.
Yeah.
1 second.
I can do Saturday. I can make time on Saturday.
Yeah, I can do Saturday.
Cool.
Yeah, what time would suit you guys better? Just because Meg's obviously running the store, so I'll help her. I'll help her out on Saturday. But if I just know when we're doing this, she knows in advance.
Does 10 work
Morning.
for everyone?
Yeah,
10.
10, I guess.
Yeah. 10's
Cool.
good.
10 a.m. Saturday. Perfect.
Perfect. Right, I'll see you later, guys.
See you then.
Right.
Good luck with the
Yeah.
laptop.
Ta-ra. Bye-bye.
Okay, I'm going to go give the doggy some food. You guys get some images, and I'll come back in a sec.
Okay.
Mhm.
Okay, so this is good. We've got an if state. We've got 6 if statements for dice 1 and 6 if statements for dice 2.
Yep.
Cool.
There's a spare bracket in there somewhere.
Oh, what, in yours?
Yeah, but I can't there, but I don't. I think it's after one of the first ones, maybe, but. Oh, there it is.
Nice. Good. Okay.
Yeah.
Cool. Okay, so one thing I could say here is there's an awful lot of very similar code, isn't there?
Mm-hmm.
The only difference between them being whether it's dice 1 or dice 2. Now, Mike thought that there must be a more elegant way, and that it looks kind of messy. And actually, beautifully simple code like that is really easy to debug and really easy to understand. If the value's 5, then show picture with appropriate name. So that's quite straightforward to understand. The problem I now have with it is the code's so similar. If you wanted to have 3 dice, what you're going to do? You're going to cut and paste and change, and keep doing that until you've got all the dice that you need. But there is a more elegant way of doing it, which is to create a partial view. And a partial view can be used many times in a view. Okay. So what we could do is we could make a partial view which takes a single die and does what you've done. And we could put that partial view on this page twice, once for each die, right?
Mm-hmm.
Make sense?
Mm-hmm.
Okay, so what I'd like you to do is go to your views folder.
Yep.
Oh, actually, yep, go to the shared folder.
Mm-hmm.
And I want you to create a new view. So add. Oh, you might need to. Is yours running at the moment?
No, it's not. I think. Is that right?
Scroll down. There you go. Raise a view. Scroll down a little bit more in that middle section, because I can see raise a view at the bottom. And what we're looking for is
It's not raise a view.
Go for raise. Yeah, go for raise a view.
Okay.
Just click on that.
I don't know if I'm.
Call it underscore die.
Okay.
Excellent. Die.
I don't know if you saw, but my Wi-Fi is a little bit unsteady at the moment, so I may cut out.
Okay, no problems. And what we're going to do is these partial views work very similarly to the non-partial views, which is you can give it a model. Okay, so this time, if you just hop back to Roll2,
Mm-hmm.
and right at the very top, what's the syntax right at the very top? At model equals game. Yeah, copy that bit. Paste him in there, but instead of the dice shaker, we just want .d6.
Yeah.
Right. So we're going to use this partial view with a die. Any die that the main view wants to give it, it will draw.
Okay.
Okay. So now go back to your dice C or Roll2 CHTML and copy one of those blocks of 6 if statements.
Yep.
Is that from 1 to 6?
Yeah. Copy any.
Oh, okay, the whole block.
Yeah, copy. Well, just 6 of them. Yeah. 1 to 6. Yeah. Or 6 to 1, whatever.
1, 5. Bit of trouble here.
Cool. That's good. Great. Now, our model, where he's pasted it from, of course, the model was the dice shaker.
Yeah.
But in this case, it's just model.
Okay.
All right. So you can just delete each first dice bit there. That's it. Because the model is D6.
Mm-hmm.
You can see that at the top. Cool. All right, and now go back to the roll 2. And I want you to delete that code that you just wrote, those that you just copied, those first 6. Yeah, just delete those. Okay. And now what I want you to do is put at render capital R, sorry, yeah. Render dot partial I might need to look this up because that doesn't look like that's working. Oh no, wait a minute, it's at html.render partial.
Okay. Is that capitalized or on?
Capital H, yeah. Okay, and it's not render dot partial, I think it's just render partial.
Okay.
Okay, backspace through render partial, just delete that and we'll see what happens when you hit the dot. There we go, render partial, perfect. All right, just click on that and then open, oh, okay, that dot's moved. You are having problems. So put the dot between the HTML and the render partial. Okay, and now that last dot you can backspace through and open earrings. And actually delete the last earring. And that one. Okay, so look, you can see here as you mouse over there, it says, okay, delete that first earring. And now just do one earring. Oh, it's putting 2 in for you each time, isn't it?
Yeah.
Okay, so you can see there it says, oh, fuck. Excuse me. It says render partial and it says 3.0. Basically, what we're going to do is give it the name and give it the model. So the partial control you want to render is underscore, but you'll need speech marks, underscore, view shared dot. Yeah, actually, that one, yeah. And then, that's being clever. That's actually no use.
Does it not?
No, it almost looks good, but okay. So speech marks. Move on. Then inside there, underscore die dot html. Sorry, CSHTML is it?
Yep.
Yeah. And then after the speech marks, you want comma, and then you want model dot first dice. So you're going to pass in the first dice to that view and then close speech marks, close earrings and then a semicolon. All right, why has that got, I think you've got a problem at the beginning. You've got a space or another underscore before the speech mark.
Oh, yeah. Mm.
Mine's coming up with the same red underline as well.
Go to the left, Fraser. Put your mouse over the earlier red. Oh, it's HTML helper.render partial.
Okay.
I think.
Render.
For goodness sake.
Should I try just render?
It might be just partial actually. HTML helper.partial.
No.
Right, I'm going to fire up mine and see what we've got. Actually, I'm just going to look for it on Google. .NET. So I'm going to search for Razor partial. Razor partial view example. Here we go. Okay, it's just at html.partial.
Okay.
He says, yeah.
Hmm.
Cool.
Still got a green underline now.
That's okay.
What's
That's
the
all right, we'll
difference?
ignore that.
Okay.
And give that a run, see if that works. See if you're still getting 2 dice images. Although I'm guessing you might not need that semicolon.
Ooh.
What's the difference between a red underline and a green?
Well, the red one is an error. I suspect the green one is some advice.
I got a unhandled exception occurred.
Is it the same as?
Same with me. Yeah.
Okay.
Partial
Uh,
die dot.
yes.
Okay, that's interesting. Look.
So it didn't look in shared.
Yeah. So I guess you need to add shared into your path there. So where you've got render, you've got html.partial, you've got underscore die. You want to put
Before that.
shared slash die. Shared slash underscore. Let's see if that works. Let's give that a try.
No. It's still looking in views slash dice, and then it's just
Why
going
did-
slash shared.
Why did we put it in shared and not just the usual view folder?
Okay. Stick it in the usual folder and get rid of the shared bit. I thought by convention people put the reusable components in the shared folder.
Okay.
But it might as well just go in the dice for now. That'll be fine.
Mm-hmm.
So yeah, just move it into the dice folder. So you've actually just moved it into views there.
Oh yeah, my
There you
mistake.
go.
Into dice.
Cool. Yeah.
There we
That should just work.
Hey.
Cool. Nice. Okay, so out of interest, do right click and view source.
Show page source.
That's it, yeah. And scroll down. Let's see what you've got. Look how little code there is there. Were you expecting to see all of those 12 lines? You know, the 2 sets of 6 values.
Yeah.
Well, this is the nice thing. What's happening is you've written some Razor code, and it only adds in the image that you want because of the if statement. So this is what I was saying earlier about your CSHTML view comprises of normal HTML, like your H1 roll 2 up on line 3 or whatever it is, and it also consists of Razor code, which is run when the page is served up, And it's saying here, well, look, if it's a 6, it will add in that image. And that's what gets written into that HTML document that goes down the wire. Do you remember in my presentation, there's that bottom right-hand chunk of stuff, and it all gets munged together and gets squirted out as HTML? Well, your if statement is only squirting out the HTML that's needed.
Okay.
Does that make sense?
Mm-hmm.
Okay. Cool. So now let's delete the second chunk and add in the partial view again.
What, so another view?
No. So you see where you've got line 19?
Yeah.
Delete all the stuff underneath for the second dice.
Do I need to copy it?
Nope. Just delete it. And now what you're going to do is copy line 19 and pass it the second dice.
Okay.
And hopefully you can see the benefit of what we just did. We've gone from 12 if statements to 6, which we're then reusing. So looking at your lines of code here, 19 and 20, you're passing in the first dice for one view, and you're passing in the second dice for the other view.
Winner, winner, chicken dinner.
Yeah.
Also, for this, the sizing of the images, I know you can change the size in using HTML. Would you have to do that for every individual one?
Well, here's the thing. I think what we'll do is, I mean, it would be useful if all the images were from the same set, so they were all the same size to start with.
Yeah, I think I'll probably just change those.
Yeah.
Yeah.
So that's one approach, but we can also use some styling to sort this out a little bit. So now we're going to move on to a tiny bit of Bootstrap learning. And we're going to use the Bootstrap grid system. Okay, so just remember that, because you can go and look it up in W3 Schools. But let's go back to roll2.cshtml.
Yep.
And look how little code there is now. Okay, it's great. The partial view is taking care of all the work. And what we're going to do is we're going to make one row of a grid system with 2 columns. So underneath that line 29 div,
Yeah.
I want you to start a new div. And I want you to give it a class equals, oh, sorry, inside the div angle bracket. So you want space.
Or inside?
Yeah.
Okay.
Space class equals, and then I want you to type in row with a lowercase r. Oh, actually, does it matter? It might do. Yeah. Okay. And then do, that's it. Do the end div on line 28.
Yeah, that's just connect. Okay.
Cool. Okay, and now we want another div inside this one with a class of column. Or actually, oops. So div, actually put it col-6, col-6.
Is that just
a
short?
hyphen? I'm sorry, a hyphen. And copy that, and let's have another one inside.
Oh, okay.
Yep. So, oh, actually, you only want that inner div. So you're going to have a row with 2 columns.
Oh, okay. So you actually just put 2.
Yeah. Now,
divs.
in
Yeah.
Bootstrap, these classes, row and column, when you have a row, the number of columns inside must add up to 12. So you can have col6 and col6 is 12, right?
Oh, okay.
You could have 4 columns of col3, or 1 col6 and 2 col3, so long as it adds up to 12. And you can read about that on that W3 Schools, okay? It's reasonably easy to grasp on there. So now inside one of those divs, I want you to cut line 19 and put it in there. So you're going to put the die in there. Cool. And put the other one in the other column. And let's have a run of that and see how that looks.
What happens if you want more than 12 columns?
You could cheat and put another row inside one of the columns. I don't know. I don't know if you would. I mean, we might find that we need to do some kind of hackery goodness. Okay, so the positioning is starting to take shape.
Mm-hmm.
They are at least on their own row now, right? Rather than one underneath and one on top.
Yeah.
So let's have a look at W3 schools. Go just, I expect yours, Alex, because you've got the same size dice, is looking a bit neater.
Yeah.
Okay. Go
But
to
they're both
Learn Bootstrap.
on top of each other.
Yeah.
And Bootstrap 4 on the right. And then let's go down and look at BS4 images. There you go. Back up, fire. Okay, so let's just go for now. I like the look of that thumbnail, right? So you guys can play with this in a bit, but let's just get it basically styled so that it looks reasonable.
Mm-hmm.
So let's add the rounded class adds corners to an image. Oh, so you could make your dice look like a rounded cornered dice, like a real thing. Okay, scroll down. Let's have a look at thumbnail. I'm going to guess. Look, there you go. That's the class name you want. You want class equals image thumbnail. So if you copy that bit of text, cool. And let's go and put that in your image. Oh, we can't. We don't have an image tag.
Can you not put it in here?
Yes, you could do, but you're going to have to put it against every one of those, which isn't a bad thing. Actually, it's not a great thing. All of your dice should be the same size anyway.
If hypothetically my dice were the same size, would I only have to do it on one?
I'll tell you what, we'll cheat. We'll cheat. Let's go into Roll2 CSHTML. And now let's put another div inside each col6.
Okay.
So we're gonna wrap the partial in a div. Oh, in which case, actually, let's go into the shared container. Let's try this in the underscore die. I'm sorry, I'm making this up as I go along.
It's all right. Yeah.
So put a div at the top there on line 3, and then put the closing div at the end.
Slash div or div slash?
Slash div, yeah, there you go. Cool, and then back on the top one, let's, oh, you got double brackets there.
Yeah.
And inside the angle bracket for div, you want class equals.
What, that image?
Yeah. Might put a space in there. Cool. Okay, and let's run that and see if that's working. It may work, it may not.
It doesn't seem to have worked for me.
No. No.
Mm.
Bastard. Okay. Let's go and put it on each of those if statements then. And that should help.
Yeah. Okay, should I take out the div?
Yeah, you might as well, yeah.
Inside, just inside
Yeah,
here?
inside the angle bracket. And in fact, it can go anywhere where you are now on that line. Just make sure you've got that space. There we go.
Yeah.
So we are now using some bootstrap classes to make us a row with 2 columns, and then we're using more bootstrap classes to force the image into the thumbnail shape and size.
Mm-hmm.
Which is failing to. That's better, actually, isn't it?
Yeah, it's not as bad, but it's not.
It's not what we were expecting, is it?
It's
changed
worked for
format
mine.
well from what it was before.
It's worked for yours, Alex.
Yeah, it's shrunk them down a bit and made sure they're not overlapping at all.
Okay. Well, I think rather than try and fix the fact that you've got odd-shaped dice, Fraser, with styling, we'll just leave you to sort out getting a coherent set of dice images.
Yeah, that makes sense.
All right. And I think that's enough for the day.
Okay.
Because that's 2 hours we've done now, and you're now looking good. I mean, you hit that, and you've got your nice values coming up. You've got your nice dice images, and when you've got a double, it's telling you you've got a double. Alex, is yours working in 2 columns?
Yep, I can show you.
Fraser's isn't, is it? It's not quite looking
Yeah, it was before, just when I put in that thumbnail.
right. Okay.
Changed it.
Oh, look at that. Sweet. And feel free to ask Alex for his images.
Mm-hmm.
I can send those over. if you want.
How nice is that?
That looks good.
Yeah, I don't know if we necessarily need the outline outside around the already outlined thing, but yeah,
No, we don't. You're right.
probably
That's
just
in the image itself, isn't it?
the little outline for this is the thumbnail thing.
Oh, okay.
Oh,
I
is
think.
it? Okay.
Yeah,
Well, you could also add in rounded corners or whatever you want.
yeah.
But anyway, that's great. Nice. Okay, looks like you boys can roll dice ready for a game of Monopoly.
hmm
Looks good, yeah.
Sweet. Okay.